Hello, today we will demonstrate clash and interference detection and clearance verification. And what is this tool? It is the tool which will determine if the two parts of your machine will crash into each other or will they work properly. And as you've seen probably in a SolidWorks assembly, you can create impossible situation where you have a part penetrating another part. And that will result, obviously, if the two parts are metal or of any other material, in a clash in a machinery. So it is physically impossible to have two parts occupying the same space at the same time. So to be sure that the parts are designed and assembled properly, we will use the interference detection tool, and essentially that tool will identify the volumes of interference, or which parts are in an interference. In this case, we are going to make a very simple example of the block base and block top, and then we are going to do the detection of the interference, and then we are going to also use after the detection of interference, we are going to remove the interferences by changing a certain parameters. In this case, it will be the diameter. We are going to increase the diameter parametrically to edit it. Finally, we will verify that a clearance exists by using the Evaluate tab and clearance verification. And the clearance will be shown there, and we can actually specify the amount of the clearance. So let's start by making the two parts as per our figure 560. Going to start making the block base, and then I'm going to make the block top or the block ring. So we start SolidWorks. We are going to switch from IPS to MMGS units, to millimeters, and I'm going to place a sketch on the front plane, and I'm going to make block base first. So block base will be made, first I'm going to make a center line, which will be vertical, aligned with the y-axis. I'm going to make one rectangle, and then the top of it another rectangle, and I'm going to specify dimensions, that the top dimension from vertical dimension from top to the bottom is 60 millimeters. 60. I'm going to specify that the thickness of the base of the block base is 20 millimeters. And now I'm going to specify diameters. And the diameters that I'm going to specify first will be for the top. I'll need to extend a little bit my center line. So I can use the center line to specify diameter by clicking on the outer edge, clicking on center line and pulling on the other side. My top diameter is 60 millimeters. And likewise, the bottom diameter is 120 millimeters. And I'm going to revolve this fully defined object, revolve boss base. And here is my completed top base. Pardon, the bottom base. If I go to annotation, right click, and click on show feature dimensions, you can see all of the dimensions being specified here, and the diameters are now specified as a phase, as a diameters. I'm going to save this part as a block base. Now I'm going to make the top of the block as a new part. And the top of the block, again, I will take it on the front plane. I will make a vertical center line. And I'm going to make a rectangle which bottom is aligned with a coordinate origin. So the 2 points are in the horizontal. Going to specify the outer diameter to be the 120 millimeters. And note that we haven't changed to the units of the millimeters yet. Top diameter, the inner diameter is going to be a 58 millimeters. And as you can see, because the inner diameter is a 58, what will happen, it will be really the interference fit. So it will be a press fit and the thickness is 20. Okay, I'm going to change, I should do this again to MMGS. And I'm going to feature revolve. And here is my top, block top. Now, if I go back to my block base, I can click on, and on the block top, let's go just to the block top, and let me make also visible annotation, show feature dimensions. As you can see, here are all of the... Okay, let's go back to our base. We are going to make assembly from base, make assembly from part, block base, and that will be the fixed one. And the next thing that we are going to do, we are going to bring the top, and we are going to assemble it by using the concentric assembly. Mate, I'm going to bring other component, top, going to make top to float.
So that's why you know where the holes are. Yeah, because you bring it, the picture will be like, whenever you do it, will be up here. I don't know which one.
Let me see what is happening here. We need to move this.
Now you take
Redrag. Okay, if I move this component up, now I can mate it. I will mate this and this surface to be a coincidental. And I'm going to make any of the two cylindrical to be concentric. Now, what can you tell me if we make this object, why it will not be in assembly like this? What is the problem here that we have?
Why? Because you haven't defined your
There is no space, so actually the hole on the top washer is smaller than the block, and it's difficult. However, in SolidWorks, you can put them, so it's an impossible configuration. So now, to find out if that's an impossible configuration, for this one it's pretty obvious because we can see it, but when you have many parts it is not obvious, especially if they can have a range of motion. So what we will do, we will click on the Evaluate tab, and we are going to click on the interference detection, and we are going to click here, Calculate. With the default, here we have certain options. And look what has happened. You see the red volume? If we eliminate that red volume, and you can see here, show your treat coincidence as interference. Include, we are not going to do that. Treat sub, okay, make interfering part transparent. So our washer is transparent. So if I click here, okay. Now what I can do? How about if I modify my washer? How about
What do you want to do?
editing my block on the top?
Yeah.
And the block of the top phi is 58. How about if I click and if I change this phi to a 60? How about if I change it to a 60? What will happen if I change it to a 60? Or 62? If I change it to, let's say, this diameter, and I need to create the MMGS, I will click it 62 mm. Look now what has happened. You can obviously see that there is like some interference, so that there is now some clearance. Now, if I go back to my evaluate, and if I click on the interference detection, and if I click calculate, it will say no interference. So now I know that I can put this washer freely on the top of the object. Now, I can check very similar like the we can check also the clearance verification. If I click on a clearance verification, let me just do before that, let me change this to the millimeters. If I click on the evaluate and if I click on a clearance verification, we can select components or we can choose all of them. So if I choose components, I will choose them from my parametric tree. I can choose and the rest of the assembly, and I can see here the minimum acceptable clearance. And let's say what it will do. If I click on calculate, what is the result? What is here? Coincident or interfering? Block base 1, block base 2. Why? Because I put, however, let me say if I put the 1 millimeter instead of the 10. Now everything is clear. Look. Now, make parts under study. Transparent, show ignored. Check. 2 millimeters. And if I go over the 4, we'll say coincidental or interfering. So it will show that there is a clearance. 2 millimeters. Okay, so this will be the demonstration of the clearance verification. So this concludes this demonstration.